of the oil and gas industry is an improvement of productivity of the wells, the reserves of which are qualified as tight reserves, or the wells with a damaged near wellbore area. To solve this problem, we designed technology which increases productivity by active pulse physical and chemical impact on a production zone, with the gases resulting from a chemical reaction between the components of a new generation of oxidizing and reducing compounds. The technology is applicable for the wells with a depth of production zone not less than 140 and not more than 6,000 meters. The technology can be applied not only to the typical formations, but also to the formations with higher content of shale. The thickness of the formation can vary from 2 up to 180 meters. Production zone can be represented in a form of sublayers. Proximity of groundwater is undesirable for the technology. Necessary requirements. To apply this technology to the specific well conditions, the following data need to be reviewed. Wells geological and geophysical data. Well design. Operational characteristics of the wells. Physical and chemical properties of the formation fluid. Technical condition of the well must allow conducting circulation operations of injected mixture and gas under pressure through the tubing and annulus. Operational procedures consist of 5 stages. Run in-hole tubing to the hold-up depth. Inject oxidizing and reducing compound number 1. Pull out of the hole tubing to the depth of 20 meters above the top of production zone. Inject oxidizing and reducing compound number 2. Leave the well for 12 to 14 hours for the chemical reaction between components of the working mixtures and thermobarochemical processes. After mixing of compounds number 1 and number 2, the pressure and temperature increases. Main thermodynamic potential of the system occurs in the formation and not in the production casing. Gas generation process begins. The mixture of gases is filtered into the formation in presence of hydrogen. The affected area of the thermobarochemical processes can be up to 80 meters and more. The rate of filtration increases by 7 times. Microfractures are formed in the reservoir as a result of impact of gases. In situ cracking pyrolysis of high molecular hydrocarbons takes place in the presence of hydrogen. This results in the opening of the closed pores and breakdown of the chemical bonds of hydrocarbons with the formation, decomposition of clathrate and hydrate compounds. One well operation takes 3 to 4 days. Ramp up the well to the operational mode takes 7 to 30 days.